Okay, so for next session, we have with us Mr. Jagrut Patel. He has done B in Electrical Engineering from LD College of Engineering in year 1997. He has done his MA in Electrical Engineering from SGSITS Indore in year 2007. He holds degree and style of Charter Engineer accredited by Institute of Engineers India. His area of competence are design of large power systems, power system analysis, which covers short circuit analysis, load flow, harmonic analysis, optical capacitor placement, design of automation, SCADA, energy audit, electrical design software development, EHV switchyard and transmission line design, solar power projects and rooftop solar systems. He has overall experience of 28 years in which he worked in various capacities. He worked as a design engineer with leading electrical consultants, carried out design of various projects, including commercial projects, township, large residential, EHV substation, developed softwares in the field of electrical design covering most of the areas like fault level calculation, earthing system design, cable sizing system, transformer sizing, DC set sizing, lighting protection system. He also carried out energy and safety audit of various industries, including cement industry, paper, chemical, and water pumping stations. So now I request Mr. Jagrut Patel to start his session. Sir, please.
Good afternoon, everyone.
Good
Thank you,
afternoon.
Rajesh sir, for introducing me. Shall we start now? Am I audible?
Yes, sir, you are audible. Sir, we can start. Sir.
Okay. Thank you, sir. So basically, we are all aware of the renewable energy, the growth, the development. Today, I just wanted to share a few thoughts on power quality issues related to renewable systems. Renewable systems means solar, wind, hybrid, very popular nowadays in India. We see the developments of these renewables since last 15-20 years in a very different scales. So basically, I have prepared the flow of my presentation in this way. We will discuss first regulatory provisions, I mean the rules and regulations pertaining to specific to active and reactive power flow. Then grid code requirements, the local, of course, we all are connecting our renewables to the local grid. So we have to adhere to these grid codes. Operational challenges in implementing those suggestions given in the codes and the grid codes. And at last, we will discuss one the case study, what we have observed. We would like to share those things to you. We can have questions at intermediate stages. So I think that is, Rajesh sir, it is allowed, right?
Yes, sir. Though we should keep at the end. The question answer session should be generally we keep at the end. But if you want, we can I can permit the participants to unmute themselves. If this way, we can do this also.
Yeah, I suggest that if the questions comes in between by raising hand, it would be better for me to, give the proper explanations to address the questions.
Okay, so no problem.
Yeah. So different abbreviations, what we are using nowadays in the development of renewable sources are listed over here. majority are very much known to everyone because we all of are from the electrical discipline, I understand. But still few jargons are there which are recently used, like LVRT, HVRT. Those who are directly connected with academics, they understand this. For the industrial people like us, it's a little bit a newer one. So basically, we are dealing with point of interaction with the grid, ABT meters, grid substations, cooling substations. Those things are nowadays into common discussions everywhere, every project. If you refer to the energy scenario, I mean, this discussion, this is not required to display it over here, but the point of discussion of this slide is this type of information you will get everywhere in a CA regulations, in a various websites of government. Everybody would like to present the growth of renewable sectors in a different manner. We know that whenever we develop some systems, it has got some inherent problems with the systems. So always the capacity celebrations are in megawatt, megawatt hour, mega units. But the problems related to that rises very well in the same tune of this growth. So if we observe a 10% growth of renewables in our system since last 10 years, 20 percentage of 10 percentage is our problems depends upon the power quality. So let us first discuss the regulatory provisions. What regulation says regarding different consumers, different generating peoples. So we have got a normal consumers here. We have clearly displayed. I think my screen is very well visible. So basically, a normal consumer who is having meter at his own premises. That is the representation over here in this slide on the upper one. For any renewable developer, the meter provision is placed at grid substation. This is the biggest difference in metering scheme. This is by the regulation of Government of India. So everywhere across India, the same is being followed. For any consumer, meter is placed. That means the transmission and distribution losses which are taking place in this transmission line is with the supply electricity company, DISCOM, or local transmission companies. Wherein the case of the renewable generating people, it is the responsibility of generating people. So losses are part of generation. They have to handle it. So whatever is available to the grid is only been metered, and further the benefits are passed on to the respective renewable developer. RE means renewable energy developer. Now, whenever we are implementing the rooftop solars for residential consumer, we do not change those schemes. So the change, what kind of changes are happening? That is a bidirectional meter at the same premises. So again, in this case, the transmission and distribution losses which are taking place in this transmission network will be the responsibility of DISCOM, distribution company. As we all know, this is implemented everywhere nowadays in India with every DISCOM. We all know many of us are having the same rooftop schemes at our roofs. These meters are only metering kWh. Okay, because these are residential provisions. So as per tariff regulations, these meters which are placed at consumers premises, they only meter kWh. They don't meet, they are not having facility to measure PQ parameters like power factor and other parameters. Okay. So whatever disturbances, whatever power qualities issues are there because of implementing solar in residential consumer part will be handled by DISCOM. This is the meaning of this. Okay. We have got another schemes as well, which is represented in the below figure, in which multiple RE developers, they are putting up their plant in a single location. They are having their own separate metering. There will be a common transmission line network up to the grid substation. There another meter is placed. So the meaning of this representation is, suppose RE1 is developing X unit and RE2 is developing Y units. Whatever net units are available at grid substation, there will be only, those units will be only utilized for a tariff distribution. Whatever benefits are there based on the tariff, it will be utilized for that. So these losses will be borne by this RE developer. So not only the losses, even the PQ parameters that has to be handled by these RE developers. We have got a very large number of residential consumers, and this is nothing but a distributed generation schemes. So whatever problems are there in these residential consumers regarding PQ for implementing solar rooftop will be a DISCOM's liability. That's the biggest difference in between these two. I think, hope you are understanding this. Now, but this is a regulatory provision. We can't change. We have to adopt this method. There is for large plants, large solar plants, large wind power, large captive power plants, and of course, hybrid power plants. Government has put some regulations on maintaining voltage, maintaining power factor at grid substation metering point. That means in the previous slide, if you talk, then at this point, I think you can see my cursor. Rajesh sir?
Yes, sir, we can.
Okay. So the voltage that and every RE developer has to maintain should be in the range of this 0.95 to, that means plus or minus 5% range. Even whatever voltage fluctuations are happening in the grid side, that needs to be taken care by this RE developer. This is what the regulation says. Okay. With power factor in the range of 0.95 lead to 0.95 lead. That means they have mentioned RE developer, they have put the clause to have 4 quadrant operations from RE developers. Now, what is 4 quadrant operations? Imagine there is a solar power plant which is generating power during day hours only, but it has to maintain voltage and power factor at point of interconnection with the grid. That means at grid substation, they have to maintain this voltage and this power factor by implementing certain things in their own power plants. So irrespective of you are having generations, during day hours, you will be definitely have generations except for rainy days in solar power plants. So at that time, if you are delivering the power, you may have to consume reactive power. But during night hours, what will happen? You are not generating anything. So irrespective of you are delivering active power or not, you have to either deliver reactive energy or accept reactive energy. So 4 quadrant operations, which are very difficult to implement for sole solar power plant, but it has been requirement raised in regulation. It's a regulatory provision, CEA regulation, Chief Electrical, Authority. They have made this regulation recently. Of course, this was there in 2013 amendments, but many power plants were established before that, 2013. So till now, it was not, mandatorily implemented, but now onwards, every power plants has to observe these parameters. Regarding over voltage, since it is a plus or minus 5% voltage, that means it can go even over voltage side also. So they have made this provision as well. 30% over voltage, you have to instantaneous trip your plant. 20% to 30%, 0.2 second you have to see. Okay, so these variations, if you can achieve within your plant, you have to implement it within by providing certain things in your plant. Okay, so this is condition regarding over voltage. Frequency you cannot do, but your equipment should be able to handle the frequency ranges from 47.5 hertz to 50 hertz. So you have to take up the equipments corresponding to this frequency range. And of course, reactive power, import and export capacity, LVRT, low voltage ride through, high voltage ride through. These all things you have to implement within your premises. This is regulatory provisions. For wind generating stations, if you see, then they are always, connected on EHV substations because wind is always at remote locations. So it is always in a bulk power mode. So always 66 kV and above EHV generating stations are there for collecting power from different windmills. For them also, they have made these provisions. So from 300 to 3000 millisecond, it has to maintain the whatever variations are there. It has to absorb those kind of variations. So this till now, this is CEA regulations, what we have talked about on PQ, power quality. Now, what is the requirement raised by the grids? See, since we are on the western grid side, I am sitting in Gujarat, you are sitting in Madhya Pradesh, someone is sitting in Rajasthan. So Rajasthan, Madhya Pradesh, Gujarat, Maharashtra, Goa, these all are connected through a western grid network. So we have got a almost a common type of tariff structure in this region. So these parameters, what I have mentioned, is mainly applicable to Gujarat and western grids. It has got a little bit changes from state to state, but more or less they are same. So first of all, those who are implementing renewable energy in this grid, they have to accept open access regulation timestamp. That is a 15 minutes, all parameter measurements, and that should be logged in the meter. It should be a transfer to the local load dispatch center, maybe a state load dispatch center or maybe an area load dispatch center. There are two different loads dispatch center. LDCs are there working for open access regulation implementation. For solar, from 7 a.m. to 6 p.m. is the time which is kept for solar type of power plants. Wind 24 hours because it gives energy throughout the day. Hybrids, hybrid has got different variations like 70% wind, 30% solar. So depends upon the type of hybrid plant, but more or less they have given it is for the 24 hours. Banking periods are different. So banking for solar is a day, wind and hybrid, they have kept it for the month. Now, what is banking? Banking is an interesting topic. Whenever you are generating power and which is not consumed by the load on other hand, so you are having a surplus generation. So those surplus generation you can keep with you for certain period. That is called a banking. Uh, for example, a residential consumer who is having, say for example, 100 units consumption per month. Normally for any residential consumers, they are having a billing cycle of 2 months, bi-monthly. Okay, so bi-monthly billing cycle में अगर you are consuming 100 units and you are generating 150 units out of your solar plants, those additional 50 units will be billed next billing cycle. So that is called a banking. Similarly, for all RE developers, solar, wind or hybrid, a banking provision is made. So those banking provisions are mentioned over here. Then for tariff billing things, there is a billing charges and billing losses. Billing losses are technical losses. So whenever we are using grid network like discoms networks, then local transmission networks or even across state transmission line network for open access usage, we have to observe these billing losses. Maximum 10% billing losses are generally deducted. So if you are generating 100 units at this place, and after this transmission line losses, if 90 units are available over here, then out of these 90 units, only 81 units can be claimed for your part after deducting these billing losses. So maximum 10% billing losses can be deducted by respective discoms. Banking charges, cross subsidy charges, billing charges, these all are the charges which are cut from your unit rate. So these all are part of tariff mechanism which one has to adhere while implementing your own renewable energy park. We can take up questions related to this later on. Regarding reactive energy, this is the provision of uh, in specific to Gujarat. JETCO means Gujarat Energy Transmission Company. We have got here transmission network which is over and above 66 kV. Those are network handled by JETCO. So whenever we are using a JETCO network for getting benefit of solar production at one point to the load at another point, we have to use this JETCO network. So in those cases, JETCO tariff order will come into the picture, and which mentions in their tariff order, say this tariff order is recently updated in 23 and 24, that if your reactive energy consumption is less than 10% of your active energy generation, then 10 paisa per reactive energy will be applicable to you. And if it is more than 10 percentage, then 50 paisa per reactive energy is applicable on your tariff. This I will explain in the case study what we have done, and which will be at the last. In renewable energy, there are two types of tariffs: fixed tariff and dynamic tariff. Now, what is fixed tariff? Sometimes for the promotion of green energy, state mechanisms, they ask people to come, and then they ask people to put up solar power plant in their own land. MP, Gujarat, Maharashtra, Rajasthan, the state's mechanism they provide land to such RE developers. वहां पर जो रेट होता है एनर्जी प्रोडक्शन का, that is always fixed and that is always by tendering way. So government opens up the tender and they ask RE developer to quote those tender. So who is what whomsoever is the lowest one, normally the tender is given to them. Say for example, in a recent tender, 2.45 rupees a unit was the quoted value and the tender was allotted to X parties. So that is called a fixed tariff, in which for next 15 years government will pay 2.45 rupees per every unit generated in that plant to that RE developer. And dynamic tariff means whenever we are putting up a plant at one place of the state and we want to take the benefit of those units generated at that place to the another place of the same plant, same state. आपने अगर प्लांट नॉर्दर्न एमपी में लगाया है and if you want to take a benefit of those units generated at northern region into Indore, because your factory is at Indore, so in that case it is your captive power plant. Now since you are going to get a benefit of those generated unit, आपका जो अभी का जो बिलिंग हो रहा है वो भी वेरिएबल टैरिफ के ऊपर ही है. One is fixed part, another one is variable part. So overall unit rupees per unit is a variable part. So whenever we are getting benefit because of this captive mechanism, it is going to be a dynamic tariff. That is what exactly written over here. So this is the difference between fixed tariff and dynamic tariff. So generally state owned RE park होते हैं, उसमें reactive power management की responsibility RE developer की रहती है. But since it is based on fixed tariff, so wheeling and other charges are not applicable. Similarly, utility owned RE park. Transmission company establishes an RE park. So in that case, the same mechanism will be there. Public sector companies, they also establish such things. These all are always by the promotion of government. Government ही इसको promote करती है. Developer RE park. Like one developer comes up and he puts up his own plant at some locations. So for him, all these things are applicable. Maybe it is a fixed one, maybe it is a variable one, but he has to manage reactive power at his end. Captive, the same situations are applicable. Small consumer RE generators, these things are not applicable at all. This is nothing but a residential rooftop solar applications. So whenever this slide is dedicated to the regulations for consumers who wants to take a benefit of tariff generating at one place and utilizing the same energy at another place. For them, out of 100% generation of solar energy, only 82.6% will be maximum utilized at the plant end. And in terms of unit rate, if he wants to get a benefit, then maximum 4.85 rupees a unit he can take a benefit. This is based on 8 rupees a unit tariff. Okay. Now different RE type and its VR management, reactive energy management. For residential, this is not applicable as we discussed. For industrial rooftop, see, this is the mechanism. This is a grid substation, transmission line, existing consumers are there. Industrial consumers है, उनके roof के ऊपर solar लगाया गया है. So meter is placed at their end only. They have to maintain reactive power consumptions. Okay, so as per the conventional method, it is been usually maintained by putting up capacitors at their end. Open access is usually not available for these kind of installations. And bidirectional metering scheme is normally adopted. Okay. Then RE in groups, that is called a group captive mechanism. Multiple people together put up a solar power plant or a renewable energy power plant at one location of the state. So their individual metering will happen. A common metering will also happen because of there will be some losses in this transmission network. Losses will be distributed among this generating people based on their generating values. So here, if you see, this is mandatory. Reactive energy management is mandatory for this kind of installations. Open access is also applicable. ABT meters are must in these cases. So the metering scheme is becoming very stringent in this case. And that is applicable for utility scale developer as well. Okay. So reactive power management will be there, ABT meters will be there. All things are mandatory for group captive mechanism as well as utility scale RE power plants. Now, challenges on implementing the things. When we talk on residential consumer, as we discussed, this is the reactive power management and all PQ power management is the responsibility of DISCOM. How DISCOM will do it? It's a big question because DISCOMs, they generally, any DISCOM, if you see, we have got in Gujarat 4 different DISCOMs, northern, western. So they are generally taking energy from the grid transmission company and then simply they give it to the consumers. They are no way in picture of implementing technical things. So how would they manage these things? It's a big question, and that is arising. So you will see changes in the tariff regulations because of this. So network handles largely reactive energy than active energy during day hours, both at night. So this is the biggest problem in residential rooftop implementation. What is happening is during day hours, it is active flow and reactive flow both. But during night hours, only active energy is there. And day hours and night hours, reactive energy is to be handled by DISCOM only. Consumers' responsibility is zero. So that is the biggest challenge. And DISCOMs are, of course, working on this part. We hope that they will come with a better solution either by implementing a proper tariff or by implementing some technical means. Industrial rooftop. Okay, the challenges are inverters are not set to manage reactive power as benefits are on kWh and not on kVARH. See, again, all renewable energy implementations are, as we talked, it is through government promotions only. रूफटॉप गवर्नमेंट एनकरेज करती है कि आप उसको लगाओ तो बेनिफिट जो उन्होंने दिया है दैट इज ऑन द यूनिट्स KWH ओनली KVARH is always a liability. So in that case consumer has to handle and they have to put capacitors. So here inverters cannot be the reactive power manager in this case. In RE groups, reactive power management is recently introduced. So now onwards, जितने भी प्रोजेक्ट हो रहे हैं उसमें ये implement हो रहा है. But those projects were implemented in last 10 years having these problems. We will discuss this point in a case study. And RE utility scale developer, there again the same thing, almost same scenarios are there, whether it is a group captive or by utility scale developer. So these are the operation challenges. The biggest operation challenge is during day hours, inductive reactance of the network. See, whenever we are developing solar power plant or wind power plant or a hybrid power plant at a remote location, say of the magnitude 25 megawatt, 50 megawatt, 100 megawatt. Nowadays, even gigawatt scale projects are also happening. In Gujarat, 30 gigawatt planning is going on. Out of that, 12 gigawatt is already implemented at a single location. The very first was 650 megawatt in 2012 itself. So these all are various scattered locations. From that, the energy is being generated, energy is being pulled up, and then it is been taken through a long transmission line up to the load centers. In Maharashtra, in Madhya Pradesh, and in Rajasthan, utility large scale projects are already in place, and every project has got this problem. During day hours, since active energy flows, all the network components like cables, transformers, okay, transmission lines, these all are having a good conduction. They are having good, current flow. So what is happening is inductive reactance is more than the capacitive reactance, and that dominates in the systems. So that will increase reactive power consumption from the grid. So these all components will need reactive power. So it will try to absorb grid's reactive energy. I mean, it will try to consume grid energy. So your active power flows from solar power plant to the grid, but reactive power flows from grid to solar. Okay, this is a challenge. In terms of four quadrant operation, this is a quadrant 2. During night hours, capacitive reactance dominates inductive reactance. There is absolutely zero power flowing through this network. Okay, only few lights in the solar plants, one or two air conditioned systems in the SCADA room or so. So as compared to the 25 megawatt, hardly few kilowatts are burning inside the power plant. So absolutely there is a zero flow of current, but since it is having complete voltage profile available, starting from EHV up to the inverter end, that leads to increased capacitive energy. So capacitive reactance dominates inductive reactance. That leads to increase in the voltage. And all those things to be handled by RE developer. Now, these are the devices generally used for handling this power quality issues. First device is inverter. Inverters are having inherent capacities to achieve four quadrant operations. Four quadrant operations means quadrant number 1, active and reactive energy both supplied. Quadrant number 2, active energy supplied, reactive energy consumed. Quadrant number 3, both are consumed. And 4 is so all four quadrant operations are possible with inverter. Inverters are having inherent feature. We have to enable that feature to implement these four quadrant operations. So earlier versions of inverters, this feature was by default disabled by inverter manufacturer. Why? Because the billing was only happening with kWh. So every developer will think of delivering maximum kWh energy to the grid to get maximum benefit out of the RE plant. But since and those days there was nothing mandatory from grid side or from regulatory side to maintain PQ at RE plant. So they were delivering only kWh. They were not maintaining any PQ parameter. Now it is been it is been mandatory. Regulation में भी आ गया है as well as grid code में भी आ गया है. So they have to maintain. So now inverter manufacturers are asked to give this feature enabled. So in a typical solar power plant, during day hours, depends upon grid's requirement, it will export active energy. Depends upon grid's reactive requirement, it will either consume reactive energy or it will deliver reactive energy. And during night hours, since it cannot export active energy, it will import active energy a bit to either to maintain this reactive energy part. So depends upon grid's requirement during night hours on this reactive energy, inverter will consume active energy and it will maintain reactive energy at point of interaction at grid substation. Okay, so inverters are best means for this, provided inverters are available. They must be in the service. They must be in a good working condition. Another conventional option is shunt reactors. Shunt reactors are mainly used to absorb reactive and to consume reactive energy. So what happens is with many solar power plant during night hours is because of capacitive reactive energy dominance, inductive reactive energy. So voltage profile goes up. So to bring it down, reactive energy consumption devices are required. So shunt reactors are used mainly for that. So if those things are happening in the solar power plant, then RE developer has to invest additionally on the shunt reactor, which cost is approximately 3,000 rupees per kVAR. For capacitor banks are also used. We know APFCR, which are used in regular industrial plants, in which we maintain power factor by using a group of capacitors, switching on of group of capacitors. So those APFCRs can also be planned to export reactive energy using these capacitor banks, and these are always in placed for a big large scale power plants. Additional investment of rupees 1,500 per kVAR is there. So we'll discuss now the case study. We have done one such PQ study for one of the plant, which was having capacity 25 megawatt AC in the location Charanka, Gujarat, which was established during 2011-12. So plant commissioned by 2012, and we visited last year 2024. So almost 12 years after completion of completion and working of that plant. Their connectivity, POI voltage was 66 kV through 66 kV cables. It has got this many voltage levels: 66 by 11 kV transformers, then 11 by 360 volt inverter transformers, and DC was operating at 1000 volt DC. Power transformers ratings were 25 MVA. Inverter transformers, multiple inverter transformers were there. 1800 kVA transformers. Inverter ratings was, this was developed using 80 watt peak thin film and 350 watt peak polycrystalline solar modules. So very beginning. You can see दो 2012 में जो टेक्नोलॉजी थी वो यही चल रही थी. But those technologies were, I mean, so sturdy. Even today, we are getting plant PR more than 75%, which is really appreciable in this case. It has got SCADA full-fledged implemented. So plant automation was done through SCADA. जब हमने वहां पर विजिट किया, we received around 65,000 data files of various, network parameters, which we accessed even. So basically, our study was to establish reactive power requirement of this plant. When this plant was commissioned in 2012, this PQ regulations was not in place. मैंने बताया कि वो रेगुलेशन बाद में हुआ है. 2013 में सबसे पहले ये रेगुलेशन आया, मतलब सीईए रेगुलेशन में उसका अपडेशन आया, लेकिन उसका इम्प्लीमेंटेशन काफ़ी ग्रिड नेटवर्क्स में बाद में हुआ. कुछ जगह 2016 में हुआ, कुछ जगह अभी भी इम्प्लीमेंट नहीं हो रहा है. इन गुजरात इट इज स्टार्टिंग फ्रॉम 2018 से उसका इम्प्लीमेंटेशन चालू हो गया है. एंड रिएक्टिव पावर एनर्जी के लिए फर्स्ट टाइम इनको नोटिफाई किया गया है, जो एग्जिस्टिंग प्लांट ओनर है उनको नोटिफाई किया गया है 2023 में. सो जब उनके पास रिएक्टिव पावर एनर्जी का नोटिफिकेशन आया, फिर देन दे स्टार्टेड फीलिंग कि अभी इसका रिएक्टिव रिक्वायरमेंट देखना पड़ेगा कि क्या करे, कैसे करे. एंड देन दे अपॉइंटेड अस फॉर चेकिंग द रिएक्टिव एनर्जी रिक्वायरमेंट. सो methodology we adopted was this. We went there and we take measurements using our cry-card meters at various locations कि वहां पर उनकी एनर्जी कितनी आ रही है. That was the first thing which we did. We also checked their existing metering scheme. जो उन्होंने already meters वहां पर लगाए थे, we compared those readings with our meter because ours is a 0.1 accuracy meter, so very highly accurate meter. So we cross-checked their meters, which was eventually feeding data to the SCADA, their own SCADA. So those cross-check things, we went site and then we made cross-check, and the results were satisfactory. So we could conclude that we can rely upon the SCADA data. Then second method was by simulating the system on network analysis softwares like ATAL. So we modeled the entire scheme on ATAL, starting from the evacuation point up to the last point of solar. And then third methodology was energy bill analysis. This plant is existing plant. पिछले 12 साल में डिस्कॉम के साथ में इसका जितना भी इंटरेक्शन हुआ है, उस इंटरेक्शन के हिसाब से जो एनर्जी बिल डिस्कॉम उनको देती है फॉर कंजप्शन ऑफ एनर्जी ड्यूरिंग नाइट आवर्स. डे आवर्स में तो जो कंजप्शन है वो ऑटोमेटिकली जो जनरेशन है उसमें से कंसिडर हो ही जाता है, बट नाइट आवर्स में इट कंज्यूम्स एनर्जी. एंड देन दे हैव स्टार्टेड गिविंग penalty on reactive energy consumption as well from 2023 after notification. तो दोनों को हमने एनालाइज किया. So these three methodology we adopted to check their reactive power consumption. This is a screenshot of energy bill analysis. We could come to know annually they are having approximately 4,08,000 penalty on reactive energy mismanagement part, since they were not having any facility to reactive power management. So reactive power consumption as well as reactive power export, for both the things they were getting penalty. So penalty in rupees was around 4 lakhs पर एनम। ये एनर्जी बिल एनालिसिस का आउटकम है। Then we establish through a SCADA report analysis how much is reactive power consumption by, I mean, the plant was divided into two part. One was having 15 megawatt and another was having 10 megawatt. तो दोनों प्लांट का फिर एक सिंगल हुकअप था। सो उसमें कितना उनका कंजप्शन हो रहा है रिएक्टिव एनर्जी का, स्काडा की अराउंड 65,000 फाइल्स रिकॉर्ड्स हमने चेक किया। वी कुड कम टू नो द मैक्सिमम इज 600 kVAR for 10 megawatt and approximately 950 kVAR for 15 megawatt systems. We also check how much inverter is consuming reactive energy. This was even our surprise. So far जितने भी एनर्जी ऑडिट सोलार के लिए हमने रिन्यूएबल के लिए किए हैं, उसमें रिएक्टिव एनर्जी कंजप्शन ऑफ इन्वर्टर वाज जनरली, वी नो दैट कि वो रिएक्टिव एनर्जी क्या लेगा, बट हियर सिंस all were central inverters, they were having reactive energy consumptions, and these are the figures what we have mentioned here. ये फिगर्स मैंने यहाँ पर पुटअप इसीलिए किया है सो दैट यू कैन कम टू नो दैट इट इज, सी व्हेन अ स्मॉल सिस्टम इज देयर इट हैज गॉट, I mean, almost we ignore them, but cumulatively it has got a value. Okay. Now, this is most important point. They were having internally approximately 5 kilometer long cabling network. सोलर प्लांट आप सभी ने देखा है, सोलर प्लांट ये 25 मेगावाट का है, तो करीब करीब ये 1.5 किलोमीटर बाई 1.5 किलोमीटर में फैला हुआ प्लांट है। सो फॉर इंटरकनेक्शंस ऑल दिस 800 वोल्ट, 11 kV, 66 kV, different voltage level, they have put up the cables for power management. So those network was having length of approximately 5 kilometer. So during day hours, since energy, as we know, अभी हमने जो डिस्कस किया वो inductive reactance is dominating the capacitive reactance. This is the scenario. Inverter TR reactive power consumption was 930 kVAR. Power transformer reactive power consumption is 1175 kVAR, and inverter power reactive power consumption was 81 kVAR. So altogether, and cabling network was having 537 kVAR. So if we put all together, it is having 2723 kVAR reactive power consumption during day hours. So 25 megawatt, 2.7 MVAR is approximately, yes, that much reactive power consumption is there. So approximately 10%. So in terms of power factor, we can say in terms of 0.85 to 0.9 power factor is the requirement of a solar park. During night hours, this is interesting. Inverter, I mean transformers, they have a constant no load parameters. So their reactive energy requirement remains same. This is a true fact, everybody knows. 930 kVAR, 1175 kVAR. Inverters are not functioning during night hours, so 0 kVAR. Cabling network were delivering this many reactive kVAR because capacitive reactance is dominating inductive reactance. So in totality, only 405 kVAR consumptions was happening during night hours. If we sum up these two, then it is approximately 2000 kVAR. But no, cabling network was helping in that way, and during night hours, 405 kVAR only was consumption from the grid. So These were the methodology adopted. Bill analysis, we established total 820 kVR for SCADA measurements. We established 1500 kVR approximately. And by calculation, it was giving me 2200 kVR. But since the penalty looking to the budget provision, we suggested them, to go with a 1500 kVR capacitor bank. Here, since inverters were from the old technology, installed in 2012, we went back to inverter manufacturers, OEMs, for implementing the reactive power management mode. They said no, that it has passed almost 10 years plus its life, so you cannot take the chance and that feature cannot be implemented. So through inverters, we couldn't implement the things. So we asked them to implement using the conventional way of putting up the capacitor banks in a stages. So 1500 kVR total implementation in stage of 300 kVR bank is implemented. So with this, reactive power management of a solar power plant is been achieved. So this is all about from my presentation. Thank you. Questions, please.
So participants, you can ask your questions.
I think participants can write the questions as well, right? This text.
Yes, they can write in chat box also. Your mic is open. You can unmute yourself and ask your question. Okay, so it seems there is no question to any participant. Sir, may I ask some questions?
Yeah, sure, sir. Most welcome.
Government is giving subsidy for rooftop plants.
Yes.
Solar. So, in how much duration we can recover our cost which we have paid for the rooftop plant?
Residential, normally we see a payback of approximately 3 to 5 years. That is subject to the capacity what we are implementing. Generally क्या होता है कि घर पे एक एसी होता है,
जी,
तो per AC we should consider approximately 3 kilowatt. If
जी,
two ACs are there, then 6 kilowatt implementation. This is a thumb rule. Of course,
yes,
we have to see yearly units pattern. तो मेरे पास एक है कैलकुलेशन है, मैं आपको दिखाऊं.
जी, 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 श्योर।
एक एक्सेल शीट है, स्क्रीन पे आ रही है.
यस सर, विजिबल।
ठीक है. तो नॉर्मली हम लोग बाय मंथली अपनी स्कीम होती है रेसिडेंशियल में. तो जो यूनिट्स आते हैं वो हम नॉर्मली यहाँ पर मेंशन करते हैं. तो जैसे अप्रैल मई का हो गया, जून जुलाई, ठीक है, तो टोटल
Yes.
6 बिल्स वी नॉर्मली पे टू इलेक्ट्रिसिटी बोर्ड, ठीक है। सो
Yes.
यहाँ पर हम लोग ये डालते हैं, और उस हिसाब से हम लोग चेक करते हैं। नॉर्मली 4 units per kilowatt per day is benchmarking figure we have established for a residential rooftop जनरेटर। मतलब आप अगर आप एक प्लांट डालते हैं अपने घर के ऊपर और उसको आप हफ्ते में एक बार क्लीन करते हैं, देन 4 units पर किलोवाट पर डे के हिसाब से आपको एनर्जी मिलती रहेगी। तो उस हिसाब से अगर देखेंगे तो मुझे 4.95, ये जो मैंने आपको एग्जांपल दिया है उसमें सपोज मैं चेंज करता हूं, तो उस हिसाब से यहाँ पर नीचे चेंजेस आते हैं।
जी।
तो ये हमारी सोलार की कैपेसिटी हो जाएगी। तो इस हिसाब से हम लोग इसको कंसिडर करते हैं। अब जहाँ यहाँ पर जैसे मल्टीपल डिस्कॉम है, उसमें टैरिफ अलग अलग रहता है। तो अगर मैं ज्यादा लगाता हूं तो जो एडिशनल जनरेटेड यूनिट्स है वो ग्रिड में चले जाते हैं। उसका जो मुझे टैरिफ रेट है वो 2 रुपये 25 पैसे से ज्यादा नहीं मिलता है। तो हम लोग ये ट्राई करते हैं कि हो सके उतना, जितना मैं कंज्यूम कर रहा हूँ उतना ही मैं जनरेट करूं। तो उस केस में पेबैक आपका 3 साल से कम होगा।
Okay.
और क्योंकि सब्सिडी में भी स्लैब्स है, मतलब अप टू 6 किलोवाट 30% सब्सिडी, 6 to 8 इज 20%, एंड 8 to 10 और 12 इज समथिंग 10%। तो आप जितना ज्यादा लगाएंगे आपको सब्सिडी कम मिलेगी, आपका इन्वेस्टमेंट बढ़ता जाएगा। और जो एडिशनल यूनिट्स जो है वो ग्रिड में जाएंगे, जिसका आपको जो बेनिफिट चाहिए वो मिलेगा नहीं। आपका बेनिफिट क्या है कि जो यूनिट रेट आप पे कर रहे हो वो सीधा सीधा आपका डिडक्शन हो जाए।
Yes.
सो इफ यू आर पुटिंग अप अ प्लांट exactly matching with your requirement, then definitely your payback would be less than 3 years, otherwise maximum 5 years.
Okay. Uh, Suppose instead of opting for net metering, if I opt for a solar battery system, how we can compare this to net metering?
Yes. Presently, if we compare solar system, मतलब module, then its supporting structure, cabling, inverter, all those, and even this bidirectional meter, that would cost you around 40 rupees a kilowatt, watt peak. So 40,000 rupees a kilowatt, उतना आपका कॉस्टिंग पड़ता है। If you implement battery system,
Yes.
then further 50,000 rupees a kilowatt peak is the cost of battery systems.
Okay.
Now,
Yes.
to charge the battery system, there is a conversion ratio, right? So
Yes.
efficiency is 90% on bidirectional.
Yes.
So when we charge using our solar generation additionally, then also, and then we discharge it, both the time 10% losses are happening. So
Yes.
20% losses are happening, approximately, I'm telling you, case to case we have to see.
Yes.
So out of that, only 80% will be available for you. So it is a huge investment. So right now it is not advisable. It is better you go by, I mean, that is what our suggestion is always. You go by, that is not economical way of implementing the things. That's the reason.
Okay. Yes. Okay.
50,000 का आपको बेनिफिट लेने में आपको कम से कम और 5-6 साल लग जाएंगे, और तब तक जो बैटरी है उसकी लाइफ खत्म हो जाएगी।
Oh, okay. Okay. Uh, I think we have a question. Yes, Dr. Kashiv, you can ask a question.
Yes, sir. Sir, good evening, sir.
वेरी गुड इवनिंग।
Sir, as you told, strict grid norms are suggested by different countries. So these grid codes are beneficial for customers or not, and from the perspective of the electricity generators, it is beneficial or not, sir?
Very interesting question, sir. See, government is in a crucial role in this case, I would say. On one side, they have to, tell people to go for renewable energy sources. But since renewable energy sources are very costly, so they have to, give subsidy kind of things, some promotions kind of things.
Okay.
But one thing is very much, important in our country is electricity is a basic need. It is put inside a bracket, basic need, like water. ठीक है?
Hmm.
And it is made available to many consumers with subsidy. When we know that with using conventional sources जैसे thermal power plant है या तो उसमें जो energy production cost है that is around 3.25 rupees to 3.5 rupees a unit. That unit they are giving at free of cost to many consumers at various places. I mean, किसान योजना में भी वो लोग देते हैं. फिर अंडर प्रिविलेज लोग हैं उनको सब्सिडाइज रेट में वही यूनिट रेट में जाता है. सो
Yes.
वेरी लो एनर्जी कॉस्ट इज देयर. So at one side, they are asking people to implement renewable energy sources, but they will not let you earn out of it. That is for sure. So you cannot make a money out of it because the production what you are doing is given to someone else with subsidy. So when government is buying energy at 2.45 rupees a unit from a renewable energy developer, and it is giving to a person who is underprivileged at say 2 rupees a unit, ठीक है, उसके ऊपर से रिन्यूएबल एनर्जी वाला अर्न नहीं कर पाएगा. तो जितने भी स्कीम्स उन्होंने दी है उस स्कीम से ऐसा हो रहा है कि इम्प्लीमेंटेशन आप कर पाएंगे बट आप उसका ज्यादा बेनिफिट नहीं ले पाएंगे. तो बेनिफिट है लेकिन वो रिस्ट्रिक्टेड है.
Okay, sir.
इन टर्म्स ऑफ पेबैक बात करें तो आपको 5 से 10 साल तक का वेट करना पड़ेगा.
Jagrut,
Yes.
Yes, sir.
Jagrut.
Yes, sir.
I'm Dr. Arya speaking.
Sir, very good evening,
Hello.
sir.
Good evening. Good evening. Your presentation was excellent. Very good. Very informative.
Thank you, sir.
Can you tell the participant about something about if I think I have missed your lecture in between the PQ capability curve of inverter?
Yes, sir.
थोड़ा सा if you can tell because that is required in the modeling, in the load flow analysis incorporated with RES.
Yes, sir.
PQ capability curve similar. I think we have a PQ capability curve in synchronous generator.
Yes, sir.
So
That we have.
If you can throw some light on what factors this depends P and Q capabilities.
Yes, sir.
Just like an alternator synchronous generator has the PQ limit.
Yes, sir. One small मैं आपको शेयर करता हूँ.
थोड़ा सा.
This curve I have shown in my slide. This is from one of the manufacturer.
Yes.
So in this case, मैंने थोड़ा इनको explain भी किया कि ये क्या है.
I missed this.
So
I missed
again,
this.
Again, sir, मैं एक बार फिर से इसको repeat कर देता हूँ.
Okay, I did.
सोलर बड़े पावर प्लांट होते हैं वहां पर ये एप्लीकेबल है। मतलब कि जहां पर 30 मेगावाट से ज्यादा, गुजरात में ऐसा है कि 30 मेगावाट से ज्यादा जितने भी पावर प्लांट्स हैं, वेदर इट इज डेवलप्ड बाय यूटिलिटी और बाय प्राइवेट डेवलपर्स, जो भी 30 मेगावाट से जितने भी बड़े प्लांट लगा रहे हैं उनके लिए ये एप्लीकेबल है।
For quadrant
तो
operation.
yes, 4 quadrant operations in which during day hours, because we have available solar, so active energy will be pushed to the grid. Reactive energy management will be there. So in case if reactive energy required by grid, inverter has to deliver reactive energy as well as active energy. If reactive energy is surplus at grid end, then it has to consume reactive energy. At the same time, it has to deliver active energy. And during night hours, it has रात को जनरेशन एनर्जी इज नॉट अवेलेबल, तो रात को क्या होगा सिनारियो कि अगर रिएक्टिव एनर्जी डिलीवर करनी है तो भी और रिएक्टिव एनर्जी कंज्यूम करनी है, दोनों के लिए इट हैज टू कंज्यूम एक्टिव एनर्जी अ बिट। तो ये 4 quadrant operation is required from inverter. This is been modeled in PSIM software. So it is a responsibility of RE developer to model the inverter in PSIM, and that PSIM model we have to submit it to the utility companies. तो PGCL है या डिस्कॉम्स है, वहां पर वो मॉडल उनको देना पड़ता है। वो एक बार उसको चेक करते हैं, उसको अप्रूव करते हैं। अप्रूव करने के बाद में हमें ये पूरी सिस्टम इंप्लीमेंट करनी है, जिसमें हाँ सर, और ये जहां पर मैंने मेंशन किया है ये LVRT एंड HVRT और फ्रीक्वेंसी रिस्पॉन्स टेस्ट, ये सारे के सारे टेस्ट उसके ऊपर पहले सिमुलेट होते हैं। वो परफॉर्म करके हमें उनको सबमिट करना है, वो लोग भी अपने यहाँ वो चेक करते हैं। एंड एट द टाइम ऑफ कमीशनिंग all these tests are happening at site prior to commission the system. और ये होने, it is a mandatory requirement. And finally ये सभी कुछ होता है एक PPC थ्रू, मतलब पावर प्लांट कंट्रोलर एक होता है, अच्छा माइक्रो प्रोसेसर बेस्ड कंट्रोलर, which takes an input from the load dispatch center and give commands to inverter to function in a desired way. So इसका इंप्लीमेंट करके कंट्रोल भी हमें ग्रिड को ही देना है, हम इसका कंट्रोल नहीं रख पाएंगे, ये प्रोविजन है।
अच्छा, do you remember we met long back and you told me that solar kWh was costlier than the conventional power plant and people are not able to purchase. I think scenario has changed now, no?
Sorry sir,
we met long back and you told me, sir, solar power normally people don't purchase because it is costlier than the unit consumed by the coal-fired plant or conventional sources. Was it so earlier?
no,
Miss
no,
per
it
unit
was
kWh cost
Yes, sir.
cost was more by solar plant, na?
सर अभी जो क्वेश्चन आया था जिसमें मैंने आंसर किया ना, वही आंसर उसमें भी है कि
अच्छा।
जब भी हम बात करें कि अगर मुझे किसी रिन्यूएबल एनर्जी डेवलपर से मुझे एनर्जी परचेस करनी है ओपन एक्सेस थ्रू, तो ओपन एक्सेस में मैं जो बीड करूंगा वो कितने यूनिट रेट के ऊपर करूंगा, या तो फिर वो मुझे कितने यूनिट रेट के ऊपर बीड करेंगे। तो ऑब्वियसली उसका जो प्रोडक्शन कॉस्ट है प्लस जो ट्रांसमिशन लॉस है प्लस उसका प्रॉफिट,
हाँ, वो एडिशनल कास्ट।
यस।
You told me earlier people were reluctant to purchase solar power from the solar generations. Was it
Yes,
so?
sir. The reason is this only. This reason is
Well,
this
earlier you told me, and I modeled this in some research paper also. Additional cost involved in optimization. I did some work based on your suggestion. Thank you for that.
Oh, thank you, sir.
Long back we met. Huh?
Yes, sir.
Thank you very much. You have presented very nicely and enlightened the audience. Thank you.
सर, होप सो कि सभी को ये प्रेजेंटेशन और जो कंटेंट है वो पसंद आया होगा। मैं इतना फ्लुएंट तो नहीं हूँ ऐसे प्रेजेंटेशन के लिए, बट आई ट्राइड माय बेस्ट.
Thank you, sir. It was really a nice presentation. So, is there any more question? Participants, please. Okay, sir. So, seems there is no question, sir. Thank you very much for giving your valuable time to us, and it was really a nice presentation. And look forward to meet you in the future, sir.
Sure, sir. Thank you, sir.
Sir, thank you very much, sir. Thank you. So we will start our next session at 5 p.m. So I request all the participants to remain connected. Do not leave the meeting.